current leads the voltage, current leads the voltage, current leads the applied voltage. So therefore it must be an RC circuit. Possible values is telling, sir, I'll assume RLC, then little bit further information needed, no? So therefore the circuit must be so we need this VRMS. What is the phase angle of this? Is 30 degrees. The current that is flowing IRMS, the phase angle of is 60 degrees. Please make a practice of slowly showing that phase angle also. But sir, till now we assumed only IA and VRMS. Later on in the numerical we were used to show, or in the graph we used to show it. So sometimes to trouble you, they may indicate like this. So there's a magnitude. So what is the magnitude? IRMS equal to how much it is? IRMS is equal to 2 by root 2 or root 2 ampere. What about VRMS? 4 by root 2. 2 root 2 volt. This will be ampere. Let this be volt. Now can we calculate the impedance? But what to do? This phase angles has to be taken care. Magnitude of impedance we can calculate from here. And what is the phase angle of circuit? So let's search the phase angle of circuit. So this is the this is the current. So this should be the phase angle. Immediately it's a RC circuit. So L should be taken out. I'm going to remove L. So now you can ask question, sir, why you are removing L? Because we have find the possible values is telling. If I assume L, again XL minus XA, how much XL, how much that will not be possible. Or you may put in exam crystal clearly, only one reactive element, one resistive element is there. Only one reactive element is there. He will mention it. So this has to be taken out. Now let's come for, we know phase angle. So from phase angle, what you can write? Tan phi is equal to XL, XC by R. We know omega, so we'll get value of RC is equal to 1 by omega tan phi. This is one thing. Next, after this, we need one more equation. Then impedance, what is the impedance? VRMS equal to IRMS into Z. And further, what is Z is equal to R square plus XC square. Or individually you calculate tan phi is equal to, we know, so XA and XR will get one relationship. I think calculations will be heavier. So we'll do one thing. Just in terms of XA and XR, first we'll work out. So there's a one equation. Equation 2. So we know value of Z from here. So solving 1 and 2 will get XC and XR. After getting XC, then use this formula. Is it okay, the phasor diagram? Then the impedance triangle, how it should be? I think you have to be a little bit careful here. So, so how the impedance triangle in the direction of current, it should be R, no? Okay, the impedance triangle. So it should be R. In the direction of, so next after this, what we get is, here you can write it, IRMS VR. Then IRMS is what? The VC should be like this. I think here not zero phase, 60 degree phase angle it should be shown. So with respect to current, it should be 90 degrees. So here what will happen? XC will come here. Then when you shift this, the impedance will come in this way. And there's a phase angle. It's not always zero phase. Here, the current is having phase angle 60 degree and the applied voltage is 30 degrees. The triangle. So sometimes they may give this phasor diagram like this. From here, you're supposed to work out. What is the power factor of circuit? Suppose if I give Z in phi, is it enough to find out R and XC? Please let me put it here only. So what is R? R should be equal to Z cos phi. Resolve Z. And at the same thing, what is XC? Z sin phi. In exams, they just give only Z impedance and the phase angle. From that, we'll get R and XC. And I'll give omega. We can calculate the components. Or from triangle, cos phi is equal to that only. Just I'm asking you to resolve component of Z along R, so along this direction, will give the resistance. Component of impedance along the reactive element will give the reactance. Please do make observation. Everything revolves here only. Most of the numericals. Answer, average power. 3
Root
plus
3.
square root 3. 3 plus square root 3. Huh? Okay, I'll write it here. Okay, yeah, fine. Thank you. Okay, no, so this is the, so sometimes it need not be always the triangle what we used to see earlier. Right? It can be of this one. Next one. It's a purely sine wave, no? You should have information of the sine wave.